Hi there, in this video we are going to develop the notion of the derivative for all 6 of our trig functions. And so we're going to start with sine x. And anytime that we don't know what the derivative of something is, we're always going to rely on the definition of the derivative. So we're going to start with f prime of x being the limit as h goes to 0 of f of x plus h minus f of x all over h, right? This is our standard definition of the derivative to come up with the derivative as a function. So for our particular function, then f prime of x is the limit as h approaches 0 of f of x is sine x. So wherever we see an x, we're going to put in x plus h. So this is going to be sine of x plus h minus f of x. F of x is just sine of x all over h. And now notice that if I plug in 0, take the limit as h goes to 0, plug it in, I'm going to have sine x minus sine x, which is 0 over 0. So this is an undeterminate form, and so we have to do something here. And oftentimes it's like, do some algebra. Well, what can we do? And so we're going to bring in our identity for sine of the sum of two things. And so let's remind ourselves, what is the identity for sine of a plus b? So the sum formula for sine is that you have sine a cosine b, and it's addition, so it stays plus, and then you change the angles. So it'll be sine b cosine a. The subtraction one is the same, the difference. So if you had a minus b, it will be sine a cosine b minus sine b cosine a. But in this case, we just need the addition formula. So now let's split that up. Using our sum formula for sine of x plus h then becomes, based on this, is going to be a is like x and b is like h, right? So then we're going to have sine x cosine h plus sine h cosine x. And then I still have minus sine x all over h. So this is our sine of x plus h. After using the sum formula for sine, we get this. Now, how does this help us? Because do I have anything in common that I can use? Well, let's see. We have the sine x and we have a sine x there. So let's write these next to each other so that then I can possibly factor out a sine x. So let's try doing that. So we're going to have the limit as h goes to 0 of sine x cosine h minus sine x. So I'm just rearranging this subtraction, putting it over here, plus sine h cosine x all over h. And so now notice that I can factor out the sine x from these two terms. So let's do that. So I'm going to have the limit as h goes to 0 of sine x, factor that out. I'm left with cosine of h minus 1. And then I have plus sine h times cosine x, and the whole thing is still over h. And now I can start to see some of my limits. So let me split this up because I recognize some limits here. So I'm going to have sine x times cosine h minus 1 over h. And then plus, well, the whole thing is over h. And I'm going to split this. I have sine h times cosine x over h. And I'm taking the limit as h goes to 0 of both of these. And so now what I want you to notice is that, notice this cosine h minus 1. I have that. I know what that limit is going to be. And I have the limit as h goes to 0 of sine h over h. What do you know about this limit? Right? We know that the limit as theta goes to 0 of sine x over x is 1. And so we can use that limit here. Now this limit is a little bit different. The one that I know is that the limit as theta goes to 0 of 1 minus cosine theta over theta, that's 0. And sorry, I just noticed I wrote x's here. This should be thetas, and my variable should be consistent. So sine h over h, that limit as h goes to 0 is going to be 1. But this one is backwards. So what I can do is factor out a negative. So take out the negative 1 and you'll be left with 1 minus cosine of h. And so I can rewrite that. So this is, which ultimately notice it won't matter because that limit is going to be 0. So having that negative is not really going to change too much. But I'm going to have negative sine x, right? Taking this negative and we're multiplying. So I'm multiplying those times. Now I'm going to have 1 minus cosine h over h. And now that limit is 0 plus sine h times cosine x over h. And now when I take my limits, I can see, oh, as h goes to 0, this limit is 0 as h goes to 0, and this limit, we already wrote it up there, is equal to 1. So what are we left with? As h goes to 0, this becomes negative sine x times 0, so that's just 0, and plus 1 times cosine x. So we just get cosine x. So this tells me that for f of x equals to sine x, the derivative is cosine x. And we can do the same thing for cosine. So I'm not going to go through the definition, but if you have f of x equals cosine x, what you'll find is that then the derivative, and I encourage you to do this on your own. What is the derivative of cosine x? Use the definition. And what you'll get is that the derivative of cosine is negative sine x. And what about all the other ones? How many functions do we have? We have 6 trig functions. So I'm going to have f and f prime. So now I know that the derivative of sine x is cosine x. If my function then is cosine x, the derivative is negative sine x. And then we also have tangent. So what's the derivative of tangent? And our other trig functions. So we also have cosecant, right? The reciprocal functions. We have secant and we have cotangent. So let's find, what about the derivative of tangent? So for f of x equals tangent x, well, we know that tangent is sine over cosine. So now I can use the quotient rule here to find the derivative of tangent. So the quotient rule is going to give me f prime is low d high, so cosine x, times the derivative of sine x, right, minus, so low d high minus high, so sine x times the derivative of cosine x, and the whole thing over the bottom square. And so let's do that derivative out. So f prime of x will be then cosine x times the derivative of sine x is cosine x again, minus the derivative of cosine x. The derivative of cosine is negative sine. So I'm going to be multiplying this by a negative sine x all over cosine square x. So what do we get? I'm going to have cosine square x minus times a minus becomes plus sine square x all over cosine square x. And what do you know about cosine square plus sine square? Yep, that is equal to 1. So I'll have 1 over cosine square x, which is, this is the reciprocal of cosine square, so that means this is secant square x. So we can go back to our chart over here. The derivative of tangent is secant square. And we can do the same thing with cosecant, secant, and cotangent. So for example, to find for f of x equals cosecant x, You can write cosecant as 1 over sine x, and then use the quotient rule here. So go through the quotient rule for this problem and see what you get. But what you should get is that the derivative of cosecant is negative cosecant cotangent. And so we can fill in our derivatives here. So the derivative of cosecant is negative cosecant cotangent. The derivative of secant is secant x tangent x. And the derivative of cotangent is negative cosecant squared x. So this will be something that you may want to put on a note card somewhere, 3x5 note card, something that you can look at often until you have memorized them. Ideally, you want to memorize this, and it will happen naturally because we use them so much. You will end up memorizing these derivatives. The ones that are used the most are sine, cosine, and tangent, but we do use secant x and some of the other ones sporadically. Maybe secant x more than the other ones, but definitely sine, cosine, tangent, and then secant, and then the other ones sporadically. You should definitely memorize all of them though. And like I said, we use them so much that it will happen naturally, but as you just start to use them, you want to have this handy so that you know what they are, especially the ones with the negatives. And oftentimes I write it a little bit differently because notice that all the cofunctions, cosine, cosecant, and cotangent, are negative. So all the cofunctions have a negative derivative. And the nice thing also, like notice that cosecant and secant, the derivative of secant is secant tangent. Add a co to them, right? So add a co, you get cosecant. The derivative is secant, is cosecant, and then tangent, cotangent. So all the cofunctions have a negative derivative. That's the most important thing to remember. And then that's one way that I remember all my other ones, right? Like tangent x, the derivative is secant square x. Add a co. So cotangent, the derivative is cosecant square, negative. So that's one quick way that I remember them. So I always kind of tend to remember sine, cosine, tangent, and secant. And then from those, I can always get the cofunctions. All right, in the next video, we will do examples of finding the derivatives using the 6 trig functions and using product rules and quotient rules and mixing them in with some general power rule and some exponentials.